All right, today we will start decision structures and Boolean logic. So what is this? Okay, I want everyone to be in this topic, okay? So if you miss this part, probably you will not be able to understand for the next 2 or 3 chapters. And, this is pretty important, please. So can you please just, if you are not writing Python, can you just please close your laptops or iPads, whatever it is, okay? All right, now I'll start again. So today we will start with the decision structures and Boolean logic. So why is that important? Well, up to now, our all programs was very sequential. What it means is we were just saying that do this, and then do that, and then do that, and so on. So there was no any other path to continue. Like if we had a robot like, and then we want to just walk around, what we were saying is move forward, and then turn right, move forward, and so on. But there was no any other option. But what we want to say is the program should decide actually what to do based on different conditions. Like if it moves forward and then say that, okay, if there's an obstacle in front of you, then turn right. But if there is no obstacle, then move forward. Or you might say, okay, maybe if there's an obstacle and the right side is, I don't know, wet, slippery, then turn left. If it is not slippery, then turn right. If there's no obstacle, then just move forward. So for different conditions, I want to put these kind of statements so that I don't need to write one instruction, one fixed set of instructions, so that the program will be more dynamic. This is what we want to do. So for that one, we first need to see these relational operators, which is, well, we want to do this comparison. Like, is it greater than that or smaller than that? Are these two numbers same or so? So we want to need to compare elements to check the conditions. And it has a certain notation close to the mathematics, but it has some certain differences. For the greater than and less than signs, it is same. But for the greater than or equal to sign, we use this greater sign and then the equal sign. It means that is it greater than or equal to? Similarly, less than or equal to, we use this equal sign. And now for the equal to sign, we don't put 1. If you put 2, it means that is A equal to B? Is 5 equal to 5? Or is 5? So whether it is true or false. If you want to say that, okay, not equal to, like is A not equal to B? Is it this way? Then we put this exclamation mark and then the equal sign. Like, and the result will be always true or false. So now this is called Boolean variables, which is like, is there an obstacle in front of you or not? Is it true or false? So again, we say 12 greater than 5. Is 12 greater than 5? Yes, true. Is 7 less than or equal to 5? No, it is false. Or when we say that, we can use also with the variables, like if x is 10 and y is 7, then how we can translate this to English? Is x equal to 10? Yes, true. Is x not equal to y? Yes, it is not equal to y. One of them is 7, the other one is 7, 10. And is x equal to 8? No, then the result will be false. We can also write in expressions here, like is x less than y plus 1? Y is 7, 7 plus 1, 8. So 10 is less than 7, 8, sorry, is 10 less than 8? No, then the result will be false. So our results will be always true or false. Like, is there an obstacle? Is it slippery? I don't know. Did I come to the end of the road, so I should turn left or right? Or when think about a driverless car, like, is the traffic lights all red or not? If it is red, then hit the brake. Is there any car in front of you? Then hit the brake. If there is no, I don't know, item, then you can maybe speed up. Check the speed limit. Is your speed higher than your speed limit or not? Then you can take action. So actually, when we are writing these kind of programs, we are putting lots of conditional statements so that the program will be able to act more dynamically based on changing conditions. And for that one, now we will see this if statement. This is a pretty important if statement because it exists in all programming languages. It exists in C, C++, Java, and all the others. So because this is a very basic concept. That's why you really have to listen this lecture, because if you miss what is an if statement, the following lectures will be pretty hard, because I will just use the if statement assuming that you already know it. So what is this? If basically is used to control the structure, and it's a keyword, so which means that we cannot give a variable name as if. And basically we say that, okay, if it is called outside, then we are ahead in the code and so on. If there is an obstacle, then turn right. So actually in English also I'm using this if statement to check, okay, if this is the case, then do this. If this is the case, then do that. So for that one, we also use these graphs, these flow charts to represent our coding actually. So to show my algorithm, if my condition is true, then I will do these things. Otherwise, I will not do that. Like if I will use this diamond sign to represent a conditional structure. If it is called outside, if it is true, then we're called, we're ahead, we're close. Otherwise, you don't need to do these things, and then you can just go outside. So this is one just a representation of our algorithm. But if I want to write it in Python, how can I do it? Like again, here let's say that here is our code. Like if score is greater than or 60, if it is true, then print passed, and then number of passed variable increased by 1. So this is my algorithm. Probably I'm going over the students, and if their score is greater than or equal to 60, then I'll say that, okay, that student passed, and I'm also counting the number of students who passed the course or not, so I'm just incrementing it. But if it is not true, I should not do it at all. So I shouldn't print passed and shouldn't increase that variable. So if it is false, I will skip those and then continue my execution here. So in a conditional statement, basically, I put some statements, but they might not run at all, or they might. So we don't know if it will be executed or not. And when I convert this algorithm to Python, now Python has a very strict syntax in that. Now I'll explain it. How is that? Well, first we write if, and then we write our condition. So a condition means basically it should be either true or false. Like, is it less than 60? Is it equal to 10? Is there an obstacle in front of me? Anything, but anything that should be either true or false. And then I put this double column. And then I write the statements that will be executed if the condition is true. Otherwise, it will not be. Like, I will say print passed and increase number of passed by 1. Now, I want you to focus on this part. There's some empty places. This is very important in Python, because Python, if I just change the indentation, the meaning of the code will change. Actually, I will show it here again with this example first, and then I will run it on Python. If x is equal to 5, so sorry, we first assign 5 to x, and then we check x is x less than 10. If it is true, print smaller. Otherwise, come here, and then check is it greater than 20. If it is true, print bigger. Otherwise, don't print it, and then come to here, and then print finish. So what is the code for it is here, but let's write it actually. So I will open my Python, and I want to first remove this part. Okay. So basically I will say if x is equal to 5, so I do an assignment just to a variable. Then I check. Now my keyword is if. Notice that it is written in a different color because it's a keyword. And I'll check if it is less than 10. Okay, I wrote my condition. Is x less than 10? And then I put my double column. And then I will write, okay, print anything what I want to write, smaller, and so on. Then I will, for now, I will just say print done. Okay. This is it. But maybe we can make it a little bit changing. I can just ask it to the user to input any number. So I will use like enter a number, let's say. So it will, the user will enter a number, and then I will convert it to int, and then I will keep it in the x variable, and then we will check whether it is smaller or not. Okay. So then let's run this code. So enter a number, it says, and then when I say, I don't know, 15, then what happened is that the code says, okay, it is 15. It checks, is 15 less than 10? No. Then it will not run this. And then it will print only this one. But if I say, when I run it again, and if I enter 5, then what will happen is, okay, it's 5 less than 10, yes. So it will print smaller. But then I will print, then it will print done. So smaller and then done. Now, I want to focus on this part. Okay, why is this space is important? Now I will do one thing. I will just change the spaces, okay? I just did it in this way. I didn't put any more statements. I just put the print done and change the white spaces. Now what will happen is, when I run my code again, and I'll hit, let's say again 15, okay, the same output that I put here. The output will be nothing. So what happened? Like I entered 15 there, and then it printed done, but I entered again 15, but it didn't print. And in the code, I just changed the spaces actually. What happened is, now in Python, the spaces has a meaning. So what I say is that, okay, this print done or print smaller is a conditional statement. It will run only this condition is true. And Python understands how can I understand that, okay, this is a conditional statement that belongs to this if statement or not. It understands it based on the space. So it checks basically, okay, I have this if statement here. Then based on these spaces, I want to say print smaller. Then maybe I want to put one more message saying that, yes, really smaller, okay? So then what I'm saying is that these two statements are conditional. They can be only run if that condition is true. But this print done, it is not conditional. It doesn't belong to this if statement. Well, how did Python understands it? Well, it checks this, okay, this if statement and this if statement, they are vertically aligned. I didn't use any space for any of it. So then say that, okay, this print statement done does not belong to if statement. It's not a conditional statement. But these two are indented to the right. So which means that then they should belong to this if statement. So when I enter a number, again, when I run this code, if I say now 15, it will not run any of these because they are conditional and my condition is not true, but it will print only this one. When I enter a smaller number like 5, oh, sorry. Let me do it again. Then what it will do is that, okay, it will check this condition, then it will run both, and then it will say done. What happened is when I change this white spaces, and if I put some more spaces, just this, I just put like 1, 2, 3, 4 spaces here. So I also put 4 spaces here. 1, 2, 3, 4 spaces here. Then the meaning of the code is changed. Now this print done message becomes a conditional statement because it is vertically aligned with those all other lines, all of these print statements. So when I do this, and then when I run my code, and then when I hit enter 5, it will run now all of them. But when I enter again and if I hit 15, it will run none of them. Because now done changed to a conditional statement. So in short, spaces has a meaning in Python. You cannot use them as you like. And also, let me say this, sometimes programming languages are pretty annoying. Like you really have to obey their rules. Like if I said, okay, I put here 4 lines of spaces, and here I put 3, okay? Note that I'm getting a warning error message, this red sign there. Normally, if I had shown this code to any human being, they would say, okay, well, you meant to this done message to be within this if statement, but you just forget one space. That's fine, I'll just do it. Normally, a human being would say so. But what a Python is saying is, I have no idea what you are saying. This is wrong, I cannot run it. Because Python will say that, okay, these 2 statements, okay, should belong to this if statement because you use 4 lines of spaces. But what is this? It has 3 spaces, and none of your code block has these 3 spaces. So I don't know how to run it. And it will not run. If you attempt to run it, I will get this error. Unindent does not match any outer indentation level. So it didn't run. So in short, yes, you really have to be careful about white spaces that you are using. And you might say, okay, what would happen if I say, okay, this is 3 lines. If I also make them all 3 spaces, then it is fine. So Python wants them to put all in line. Whether you use 2 spaces, 3 spaces, or maybe I'm just hitting the tab character here. Let me also do it here. That is fine. It doesn't, as long as you use the same indentation, then Python will understand, okay, this is the same code block. But if I use, okay, tab and the space, I will get an error. Do you have any questions so far? Okay. I would like to warn who are looking at their phone or the tablets. This topic is important, okay? Because throughout the semester, then we will use if statements a lot, okay? And now for the comparison part, just some more example. Like you can always translate this to English. Like if x is equal to 5, then print equals 5. If x is greater than 4, then print greater than 5. If x is greater than or equal to 5. If x is less than 6. If x is less than or equal to 5. If x is not equal to 6. So actually it's pretty straightforward to translate it to English. And here we have one-way decisions. What it means is I just defined that what to do if this condition is true. Like if x is equal to 5, then run these statements. If it is not, don't do anything special. Just skip here. Don't run it. So I have only one way. If this is the case, then do that. Like if the engine is not working, then turn the key and run it. If it is not, so if it is already running, then you can just move to the next step also. But I have only one condition. If engine is not running, run it. If the computer is turned off, turn on. I don't have this the other condition. I have only one-way decision here. Let me check if I am missing anything here. I think I'm not. I'll just continue. Yeah, this indentation is pretty important. Again, now, this is just one more example. Now, we have this x is equal 5. And then we have this if statement. They are vertically aligned, this if statement and this x is equal to 5 assignment. Then to define the block for this if statement, I use this indentation. So these print messages, they are vertically aligned. And then I have this print done with 2. Now this is vertically aligned with these first if and x is equal to 5 statements so that it doesn't belong to this if statement. Then we have for loops, which is we will see in chapter 4. For now, we don't need to know what it means. But this indentation rule also applies in that. Like these statements belongs to for loop. How I understand it, they are indented. And within a for loop, I define an if statement. And this print message belongs to if statement. How I understand it, I indent it even more. So that I know that, okay, this belongs to an if statement, but these code blocks that are vertically aligned, then they all belong to this for this for loop. And then I understand, okay, this print all done does not belong to this for statement because it's also vertically aligned with those lines. So again, this indentation of the statements changes the meaning of your code.